started. So I just want to review matter and energy. If you see on Google Classroom, there's a form to fill out with some questions. Again, some of you have filled it out, some of you have not. And I want to say that the rate of answering the questions on average was a 3 or 4 out of 5. Nobody got a perfect score and nobody completely got the concept wrong, but let's just go through just again, just so we can be on the same page moving forward. So remember that matter, again, is anything that has mass or weight or takes up space. And there are 3 phases of matter: solid, liquid, and gas. And you can have solids, liquids, and gases that are elements, solids, liquids, and gases that are compounds, and some that are mixtures. So just to review the differences between elements, compounds, and mixtures, remember that elements and compounds, sorry if it's messy, are both pure substances, okay? What makes them both pure substances is that they are in a definite ratio, that you could break them down chemically, but you cannot break them down physically. And elements you can't break down chemically or physically because it is the smallest particle of matter. And compounds are 2 or more elements chemically combined. And both elements and compounds are both pure. So anyone who has a sample of magnesium, it's going to be the same whether you get magnesium from here or magnesium from California. It's exactly the same thing. And H2O, no matter where you get it, is pure H2O. Carbon dioxide is pure. It always has the same ratio. It's always made the same. You can break it down chemically, but not physically. So if you had, for example, carbon dioxide, it's always in a 1:2 ratio, and they can be chemically decomposed into carbon and oxygen, okay? Whereas mixtures, they're physically combined. So salt and water is a mixture. What about, like the air you breathe is also a mixture. It's a mixture of oxygen, nitrogen, carbon dioxide. It's a big mixture of substances. Let me go right. Okay, so different types of elements are like hydrogen, oxygen, magnesium. Those are all different types of elements. And it's pure.
You just told me right now that she can come here.
Positions or made through synthesis. If you can shut off the volume on yours, if there's background noise, that would be great. Someone has their volume on. Let me know if I should mute everyone, but.
Do we need to take notes?
No, I'm gonna put this back up after. It's just pretty much, I looked at some of the answers that some of the students have already given on the Google Sheet, on the Google Classroom. And I see that some of you were unsure about what makes a pure substance, which are elements and compounds. What's different from that are mixtures that are physically combined. So just taking it from the most complex here, a mixture is physically combined. You can physically separate it. Whereas compounds, you cannot physically separate it, but you can chemically separate it. And elements, the smallest, you can't chemically break it down or physically break it down. So understanding if you're given an example of which one of these is a pure substance, you would have to say whether, an element or a compound, or if you give an example, like for example, sometimes they give you NaCl aqueous, that is a mixture and that can be physically broken down. Whereas NaCl solid is a compound that cannot be physically broken down. So when we're talking about physically combined or mixtures, there are different types of mixtures. We have heterogeneous. Oh, two people are waiting. We let them in. And we have homogeneous. Homogeneous, another name for homogeneous is a solution. So if, for example, take some water and salt. So here's water. I'll drop this on the ground. Okay, and if I put like, salt in it, it's going to dissolve. And that is homogeneous. That's a solution over here. It's going to dissolve. It's going to spread out throughout. You're not going to be able to say, oh, there's salt or there's salt because it's all dissolved throughout it. Okay? And remember how to separate this homogeneous mixture or solution. You would do that by boiling or distillation. Those are both physical separation techniques. So you separate, oh, that pen doesn't really write very well. It's distillation. Distillation means to separate by boiling, okay? They have different boiling points. So because salt has a very high boiling point, you're not gonna be able to boil the salt in your kitchen. Meaning if I put this in a pot and I boil it, the water will evaporate and boil off, and the salt will eventually be left behind. Which is different is if I take pepper, I don't know if you can see it on there or not because it's kind of hard to see, but I'm putting pepper in here now. Can you see, if I move my hands away, the pepper particles? I can't tell if the resolution is high enough on there or not, but there's pepper in there, and the pepper is going to settle to the bottom. So that's heterogeneous over there. I can definitely see the particles of pepper. They're not dissolving. And if I wanted to filter this, it would filter out. Let's see if I can do that. Get a paper towel. This doesn't make a mess, but if I pour this in, you can see that something's going through because it's not great paper towels. But on top of my faux filter paper, you'll see that a lot of the pepper, can you see that, was filtered. Can you see that? Yes? Okay. So
Yes.
that you can filter a heterogeneous mixture and separate the water into the glass, and then the pepper stays on top. That's a precipitate. Okay, so whenever you see the solid that's on top of that filter paper, that's the precipitate. Okay? So you precipitate at the bottom, and you can filter it out. So precipitate is the solid stays on the filter paper. So the big thing that you need to know is that you can separate a heterogeneous mixture using filter paper, homogeneous by distillation or by boiling. So what typically the regions will do is give you two aqueous solutions that are mixed together, and they'll say, when you filter it, what is going to be the precipitate that stays on top of the filter paper, and what's going to be the aqueous liquid that's left behind, and you would use table F to figure that out. And obviously, if there's no chemical reaction, then you just end up with whatever you started with because nothing happens. But if there is a chemical reaction, you have to do the double replacement, see which one will be the aqueous product and which will be the precipitate product. Okay, so that's a little bit of an overview of matter. So you have the pure substances. Oh, there's a waiting here. Okay, so again, just matter, you have your pure substances, elements and compounds. which cannot be separated physically. Mixtures can be separated physically, either by using a filter for a heterogeneous mixture or distillation using a homogeneous mixture or solution. Elements, the smallest particle of matter, cannot be physically broken down, cannot be chemically broken down. And all three of these can exist in solids, liquids, and gases. So you can have an element that's a solid, like magnesium. You can have an element that's a liquid, like bromine. You can have an element that's a gas, like oxygen. Similar compounds can exist like solids, gases, and mixtures as well.
She is the vice principal of the school. And she's also my teacher.
So that's the overview.
Can you guys mute yourself?
Thank you.
I did.
So what I'm going to do right now is, this is all recorded. I'm going to save the recording and share it, so if you have any questions on it. But if you go back to the Google Hangout area where we were having like that text conversation before, if you have questions about any of this, if you have questions about anything on the Google Classroom for today's lesson, it's a mini overview and a catch up just to refresh everything before we move forward. I'm going to be online, so you can ask questions of me or of each other. That's fine. Or, you know, after in the office hours, I'll be backlogged on between 2 and 3 p.m. every day to answer any questions you might have. And then also on Fridays for office hours as well during the science block time. Got it? All right, so if you joined kind of on the later side, I am going to stop recording.